I've just become the proud owner of the Domino 500, and I want to give you my first impressions as well as combine all the advice I've gathered into one concise video. Now, confession time, I've currently never used this tool, and I've never used any domino for that matter. But if YouTube has taught me anything, it's that while this tool is divisive, it's also a brilliant tool that's also super easy to use. Now, my thoughts were that it was going to be much like a biscuit jointer or most any other tool in the workshop that's intuitive how to use it. But when I first got the tool and took it out the packet, that wasn't my experience. I honestly found it all rather confusing. Now, I'm sure I could become adequate with the tool if I would spend some time with it, but I went on a bit of a research mission, and the more I learned, the more I realized that to become good with the tool and to get the most from it, you really need to spend a bit of time sitting down and learning how to use it. So get comfortable and let me show you what I found. Before I start making any joints, let's first familiarize ourselves with the tool, starting with recognizing that everything on this tool is in metric. Now, that's music to my metric-loving ears, but if you aren't so sure, just remember the conversion that 6mm is roughly equal to 1/4 of an inch. And if you can remember that one conversion, you should be able to calculate all the common woodworking dimensions. But also, within the bubble of the domino, because all the dominoes, all the measurements are metric, it's easy enough to work out. The first true feature I want to look at is the fence, and if you're familiar with a biscuit jointer, then it's very similar to that. You just loosen this lever and then move the fence to the desired angle. It has little index points that will keep you right on all the common angles, 0, 45, 22.5, 90 and so forth. And then you just lock off the fence when you're ready and you're good to go. Now if you're plunging, you want to be at 0 degrees. For a standard panel joint, you're going to be looking at 90 degrees. Setting the fence height is a little bit more involved. You loosen this lever and that will allow the fence to move up and down. And then to set the height, you've got two options. You can use this gauge here, which will give you the measurement from the fence to the center of the mortise, or you can use the selection slider, which measures the material thickness. Now, know that if I set the selection slider to 40mm and I just move that into the window, put the fence down and lock it off, the gauge measures 20mm. So just remember, this is material thickness and this is from the fence to the center of the mortise. Now, a little tip here is to get the most from this tool, repeatability is key. So I would recommend using the selection slider wherever possible, even if that means your mortise is a little bit off center. It should be much easier to find the exact same height in the future, and so it's much more repeatable and a much more certain thing. The next feature to look at is the mortise depth setting. Now, if I'm using an 8x40mm domino, the chances are I want that joint to be in the center of that. So 40mm divided by 2, 20mm. That means I set the mortise depth to 20 and I'm good to go. The only exception to that is with the newer 4x20mm dominoes. And if you want a simple rule to follow, you just need to set the mortise depth to 20. But if you prefer to understand the logic, then what you need to understand is for different thickness dominoes, you need a different diameter cutter in the tool. And all these cutters are the same length, except for the 4mm cutter, which is 10mm shorter than the rest. What that means is you need to add 10mm onto any mortise depth that you want. So in the case of this, it's 20mm long. I want it in the middle, 10mm, but plus 10, I get back to 20, and hence 20mm.
The final setting on the tool is mortise width. Now, a very important thing to note here is only rotate the dial when the machine is on. This seems counterintuitive, but rotating the dial with the machine off can bind the gearbox and damage the tool. Apparently, there's many dominoes returned each year because of this very issue. Rotating the dial switches between tight, medium and loose settings. For the most part, you'll be using the tight and medium modes.
And lastly, let me show you some useful dimensions to know about on the tool. Starting out with these metal tabs here. Now, they're machined to be exactly 10mm from the base of the tool, which also so happens to be the exact center of the cutter. So if you ever need to reference the center of the mortise, use these tabs. Also, these stop latches are 37mm from the inside to the centre of the mortise. These latches are used to position your first mortise from the edge of your workpiece without the need to mark anything. Although if you're like me, you're probably wondering why 37mm, why not a nicer number like 35 or 40? Well, I think that's probably for our imperial friends, and 37mm is pretty darn close to 1.5 inches. Next, let's talk about the Domino, because it's a much smarter design than you might think. Firstly, it's made from European beech, just like most dowels, which is a great choice because it's a very strong wood, it's clear grained and it's sustainable. But it's the design of these that's the really clever part, starting out with a rather obvious aspect of them being flat. This provides much more gluing surface area, so a much stronger joint, as well as being able to resist some twisting motion and aligning the top of the boards. Of course, there are situations where a biscuit or a dowel will be able to do the same job, but I'd argue a Domino will more often than not do the job better, but mostly it's one tool to do the job of multiple. When I measure a 10x50mm Domino, it's exactly 10mm across the flats, but the length is around 2mm shy of 50mm. Since the mortise is exactly 25mm deep on each side, the slightly shorter tenon will prevent any snagging when it's glued up. But because Festool continues to refer to this as a 50mm Domino, it keeps things simple for us. You'll also notice the ridges on the rounds of the Domino. These provide channels for the excess glue to escape. And lastly, they have depressions on the main face that carry the glue into the mortise. There are many different sizes of dominoes, but the common ones are 10x50, 8x50, 8x40, 6x40, 5x30, and the new 4x20. I was a little uncertain at first what size joint I'd need to use for each application, but there's a very simple rule of thumb, and that's use a tenon or a domino that's a third the thickness of the material you're working with. So if you're using 18mm ply, you'll want a 6mm tenon. As for the length, that's a little bit more complicated, and it depends what strength you want to achieve, as well as what joining method you're using. If, for instance, you're joining 18mm board like so, then a 6x40 domino is ideal, but if you're joining it this way, then the same domino would break through the board here. So what we need to do instead is offset the mortise this way, or use a shorter domino. I think the thing to know here is that Festool have put a lot of time into deciding what size dominoes that they'll sell, so when the need arises, it becomes quite intuitive to know which domino to go for. When seeking out advice for this video, there are a few hints and tips that I came across that I think are the main differences between an adequate and pro user, starting out with how to hold the tool. The obvious way to hold the tool is like this. That's where the power button is, that's how you hold similar tools, and that's how I suspect Festool designed the tool to be held. But apparently this causes the tool to lift a little when plunging, which means your joints won't align correctly. Instead, the pros hold the tool at the power cord, being sure to support the entire weight of the tool from the fence handle. You should be able to stay relaxed and let the tool do the work. If you're tensed, you will increase the chances of things going squint. If you hear chatter when plunging, you're probably going too fast. Try slowing down and moving more consistently. When joining a mitre, the mortise wants to be as high on the board as possible. This is to prevent the mortise penetrating too deep and bursting through the board. For this reason, it's important to set the fence angle first, then the height. If you do the height first, the tool can foul here, limiting how low it can go. Next, make sure you're always referencing your workpiece from the fence of the tool. With 18mm boards in particular, the natural thing to do is set the selection slider to 20mm. Now, that's a perfectly fine thing to do, but with the stack up of dimensions, it can actually mean that you're referencing off the workbench onto the base of the tool rather than the workpiece onto the fence of the tool. Mark all the top surfaces of your workpieces so that you can be certain you're always referencing the tool from the same surfaces. It's an obvious tip, but not doing so has tripped up many people. When making butt joints, make sure you're always referencing the faces that you want to align. Again, I'll demonstrate the correct technique in a little bit. When using the stop latches for your first mortise, pivot the tool in to get a reliable position. And it's best practice to make that first mortise in the tight setting and then the rest of the mortises in the medium setting. This should give you a little bit more wiggle room during the glue up, and it won't weaken the joint in any meaningful way. And last tip is to leave 150mm to 200mm between dominoes. So at long last, I can stop talking and I can start to use the tool. Now, I must admit, although I'm excited, I'm also quite nervous about using it. Not because I'm nervous about the tool itself, but because I'm doing it on camera for the first time and I don't want to look silly. But I did say I'm going to give you my first impressions and first use, so I promise I won't be editing out any mistakes to make myself look better. So instead, the plan is to make these common woodworking joints using the best practice of what I've learned so far. And coming from an engineering background, what I like to do in situations like this is create a part that tests the machine to its max. So I've created this beautiful part, and from this starting point, the plan is to add a butt joint, and then a bevel joint, and then a panel join using the cross stop jig, a mitre join, a shelf join, and then add these pieces with the trim stop jig.
For my first time using the tool, I wanted to cut some mortises into a scrap piece of wood using the tight, medium and loose settings. As I wanted to do this with an 8mm domino, I obviously needed an 8mm cutter, and the stock cutter was a 5mm, so I had to swap them over as you can see here. Thankfully, this is a really easy process. Another tip that I did pick up in my research is don't over tighten the cutter, as it can be hard to remove if you do. Now, this was my very first time using the tool, and as you can see, I've immediately defaulted to that standard hand position as opposed to the power socket hand position that I was recommending. But even with that, I got a very good result. I was able to go from the tight to the medium to the loose settings without problem, and it felt very familiar. It felt just like a biscuit jointer, and all my holes were perfectly square, straight, exactly where I wanted them. As I made more holes, I experimented with different hand positions, and I could sense the potential for that pivot action to take place, but as long as my right hand held the fence down securely and I was conscious of the problem, I think either hand position could work. The socket position was maybe slightly preferable, but as long as I build the right muscle memories, I think either approach is possible. While those first holes into the side went very well, unfortunately the same couldn't be said when I attempted to plunge with the tool. While trying to switch the tool on, the motion of the power switch is not easy to access while in plunge mode, and while trying to switch it on, I accidentally plunged the tool and switching it on at the same time into the workpiece, marking it up. Definitely something to be very cautious of moving forwards. The next problem I encountered was aligning the tool to the pencil marks. I found that the pencil marks needed to be extended very far in order to be seen, but also with the vibration of the tool and limited friction at times, then the tool had a tendency to vibrate away and move out of position. Rather than having the tool floating on the surface like this, I believe the better approach would be to have it referenced up against a piece of wood, which is the approach I'm going to take later on. That's all the pieces milled up for the sample part, and I'm going to connect those with a 5x30 domino, so the first job is to put the 5mm cutter back in. And the great thing about changing the cutter is you get to make this noise. I've milled up all these boards to exactly 20mm, so I can set the selection slider to, you've guessed it, 20mm. And I set the mortise depth to 20mm as well.
So what I'm going to do here is I'm going to start out by marking the top surfaces so I don't get mixed up at any point. Then I'm going to make sure this side is perfectly flush. I'd like to reference off this edge, but 37mm across would put the domino around about the middle, and because I want to try and get two in, instead I'm going to measure 20mm from each edge.
And then I align my pencil line with the center mark on my tool and cut two mortises in each piece. In this case, I'm cutting all my mortises on the tight setting.
So that didn't really go to plan. First of all, these are actually 5x30mm dominoes, and so I should have set the mortise depth to 15, not 20. And second of all, while I have a lovely flush surface here, this surface here is about 1/2 millimeter off, and I can even see that the pencil lines aren't lined up. So there's a few ways I can approach this, but what I'm going to try and do is separate them and then re-drill this mortise, still in the tight setting, but hopefully I just didn't line up the pencil line properly. Didn't fix it, still have a step, so I'm going to try the same here. Out of curiosity at this point more than anything else, and if that doesn't work I'm going to have to put it onto the medium setting. Again, it didn't feel like I did anything, but hopefully I think I've got it. So I must just have not taken enough care when I did the first ones. For the bevel, I'm going to use the stop latch on the tool to get the outside mortise, and I'm going to do that as a tight mortise, and then the inside I'm going to line it up to the pencil lines, and I'll do that as a medium width mortise. So that all went to plan, and hopefully doing it this way means the top tight mortise will keep the whole thing in alignment and keep that corner just perfect. And yes, we have success. For my panel joint, I'm going to start out on this side here, and I'm going to put in a tight mortise around about there. And to do that, I'll reference off this edge using the stop latches. I'll then put in subsequent mortises at 140mm spacing, and I'll use the cross stop jig to achieve that. Now, bear with me here, but as I understand this, this pin references off the mortise, and it will be pulled along off to the side of that mortise. So if I want the center of my mortises to be 140mm spacing, I actually need to subtract half the width of that mortise. So I've set this to 130 with the hope of actually getting a mortise spacing of 140. Now that sounds a bit off, so we'll see if my theory is correct there. That seemed to go well, and if I just measure the mortise spacing, I've got 141, 142, 142. So that says my theory is correct, and the reason this spacing is less than this one is because this is the wider setting. Now let's join it up and see how we go. Perfect. One other thing I'd like to draw attention to is these pins, I suspect, measure just under 5mm. So when drilling a 5mm mortise, they struggle to actually reference inside. If using a 6, 8, 10mm mortise, I think this jig will work great, but for the smaller sizes, it's maybe not so appropriate. For the mitre connection, I'm going to measure 20mm from each edge, and I'll hope to get a better result than I did here. I'll then set up the tool, setting the fence to 45 degrees and then lowering it until we have metal on metal contact here. Although it looks a little dubious, everything was actually well supported and it felt quite stable. And the moment of truth. Well, that's pretty terrible. This edge here is bang on perfect, but again, we're stepped out and I cannot figure out why. I found the problem, and I must admit I'm quite surprised at what I found. So I've checked, and this line is bang in the center of the tool and therefore bang in the center of any mortises that are cut. But this line here is not in line with this. It's about 0.5 mm off. And when you think, the way I was cutting that mitre just now, it would have been 0.5 millimeter off to the right when I did my first mitre and 0.5 millimeter off to the left when I did my second mitre, which is why I'm about 1 millimeter off now and why it looks so terrible.
To calibrate the tool was quite straightforward. I just extended the line from the base of the tool onto the fence and then aligned the gauge to that line. There's some slotted screws on the bottom, so I just loosen those off, get it in line and tighten them up again. I'm not sure if I was naive for not double checking this straight out the box, but honestly with the price of the tool I did expect better. To confirm I fixed the problem, I put together this part. I'll make 3 tight mortises, each lined up to the pencil line.
So that mitre came out absolutely perfect, and it also goes to explain why my mitre joint and my first butt joint were so far off. So a top tip, don't take for granted that your gauge is set up correctly out the factory. I did have more faith in Festool, to be honest, but I'm pleased I made this video, because had I not been making this video it might have taken me a little bit longer to figure that out, and it could have been very irritating if I'd found it out on a nice piece of furniture. So check that gauge. Next, and I have to admit I'm looking forward to this one, I want to do a shelf join. So what I'm going to do first is square it up and put a line on my piece just there. Then I want to put a cross in the joining corners like that, and the idea is that these two crosses are going to meet up together. Then ensuring that I'm bang on that line and bang square, I'll clamp that down. I'll then bring the tool in, and my plan is to put a domino in here and a domino here. And if I go in from the edge, referencing from the tabs again, then I know doing it this way, the mortise will be 10 mil up this face here. And then if I plunge this way, I know it will to be 10 mil back from that edge. So when it goes together, it should be bang on that line.
The tight mortises are rightfully so very tight. This can make assembly difficult, but when doing test fits, it can make disassembly even more difficult.
And that is incredibly satisfying. One of the easiest cuts and perfect results. And the next joints I want to add are these here. And I'm doing these primarily to explore this trim stop jig. But to do that, I'm first of all going to have to remove this piece here. And there's probably a lesson there. If you are doing a dry fit, it can be worth sanding down these edges just so that the dominoes come in and out a bit easier, and then keeping those dominoes aside for your dry fit dominoes. I've changed my mind a little bit here how I'm going to assemble this. I was going to do it like so, but just so I can do a few different kinds of joint, I'm going to do it like this instead. So the place to start next is to add a center line to the center of one of these pieces, and it's important to be as accurate as possible here. Once you've done that, you want to get the jig onto the tool. And the best way to do that, I've found, is to make sure these tabs are all the way out, and then with the fence in the 90-degree position, you slide it on, bring the tabs in, and tighten up the toggles. And then we're just going to set this up to back to 0 degrees. I've set the tool up in the vise here just to make it a little easier for you to see. And if I put the piece of wood in here, then the idea is to get my center line in line with this gauge here. And when I get it bang on, just tighten the toggles. And if you project it down the way as well, coincidentally, this is probably also a very good way to check that your tool is calibrated properly. As you can see, it's lined up with the gauge, it's lined up with the little pencil mark I made, it's lined up with the mark on the bottom of the tool. What I'll be doing here is I'm going to be adding a mortise that way and a mortise that way. So this one, these two here need to be vertical mortises, These ones need to be side on this face, and we obviously need ones here as well, and they will be in line with these pencil marks I've already made, so I'll just extend those. Okay, and for the tool, what I need to do is first of all, I'm going to set the fence to 90, then I'm going to lower it so that it's 10 mil high or 20 mil material thickness. I can then slide the part into the jig like so and plunge away. Then move the fence to 90 degrees. And I want to put a vertical into this face here. So again, I put it into the jig. And flush it up to this edge here. Can then remove the jig and set the fence back to 0. And then I can line up to these marks. Then to give me a little clearance, I'll just remove these and add the final mortises. And I should just be able to assemble. Perfect, spot on. And I should be done there, but I did think up one more joint that I'd like to do, and that's an edge butt joint. So I'm going to put 2 dominoes, one here and one here, using the stop latches to reference the edges, and I'm going to use the fence to reference this face and this face, as those are the edges that I want to be flush. And then I've set up the tool with the fence set to 90, material thickness at 20, and I've added the support to give me a little extra stability when I'm plunging. And that is this part complete. But before I give you my first impressions of the tool, let me give you a few pieces of advice that I hadn't come across before and I think will be really useful. Starting with maybe rather obvious, but you've got to support the workpiece properly. For me, working with this smaller stock and on this slippery surface, I found it rather difficult to feel the tool and feel if it was registering properly. So I'm going to be correcting that by adding a piece of T-track along here so I can add clamps for basically any size workpiece. Additionally, you've got to think about your stock. You really need to have well milled up stock that's exactly the right proportions. The tool won't correct incorrect stock, so you do need to pay attention to that. And the last thing is the switch. I did eventually work out how to switch the tool on in the plunge mode without accidentally ruining your part, and that's by pinching between the base of the tool and the switch. You have to pinch quite hard, but when you do that, it prevents it accidentally ruining the piece. And so what are my thoughts on the tool? Well, look, it's super easy to use. The dust extraction is perfect. It's easy to get great results and across a whole range of different applications. But it's a tool that I'm going to have to continue to learn to use, and it's going to take me some time before I'm going to be able to just use this tool without having to really think about what I'm doing. And I'm okay with that. I think some tools will require a bit of learning to get the most from them. And I think this is just an example of one of those tools. I can't avoid it any longer. Let's talk about the cost of this tool. You know, there's lots of people out there that love to hate this tool for various reasons. And I have to say, I'm not in that camp, and I have never been in that camp. Maybe it's because I come from a product development background, but I see that Festool came up with a concept for this They paid to develop that concept. They took the risk on of bringing it to manufacture and bringing it to market. So they have a certain privilege there to charge what they like. And there is no competition to this. So, you know, that's their privilege, I suppose. Now, don't get me wrong, it was a tough pill to swallow when I purchased this tool, but there's a good argument there of, you know, time is money or time is survival. We're a new content-based business, and if we don't get that content out as quickly as possible, then we won't be here anymore. We don't want to compromise on quality to get quantity, so a tool like this allows us to get stuff to you and hopefully still be around in a few years. And it's not just this tool, there's other tools that we've just been purchasing in the workshop to try and make ourselves more efficient, and by doing that, hopefully, we'll be here. You've also got the sort of traditionalists that say, you know, use a proper mortise and tenon. And for me, like, I like technology. I'm not so much about, I suppose I do like the act of creating it, but more so I like the final product. I like the creation process, not necessarily a particular element of that. And this is just a modern part of that process that allows me to do things faster, quicker, better, you know. It's a good tool, and so I'm going to pay up, and I've never spoken to anybody who owns one that regrets it. That says something, I think.